We are going to begin today's lesson by writing down the I can statement, which reads, I can solve linear inequalities by addition and subtraction. I'll give you a second to do that. As you're writing that down, I'm going to read over this information box here. The open statement contains greater than, less than, greater than and equal to, less than and equal to is called an inequality. We've seen these before. So then in this key concept box, it's telling us that if we have A is greater than B, then we know if we add the same amount to both sides, so in this case C, that A plus C will still be greater than B plus C. Then if we can say the same thing, that if A was less than B, then A plus C would still be less than B plus C. We're going to solve the following equation like we normally would, where we will start by drawing down some equal bars so we don't forget to write our equal sign at the end, in this case our inequality sign. And we're going to solve for x, so we need to add 12 to both sides, like so, crossing out our 12, leaving us with x is going to equal, or x will be greater than or equal to, 20. So we will write that like this. I like to write my inequality sign in a different color so that I remember, hey, I need to make sure it's an inequality sign, not an equal sign. In order for us to check our solution, which is the next part, is we need to pick a number, and that's going to be greater than 20 because we saw our solution was x has to be greater than or equal to 20. So in our check here, I'm choosing the number 22. So if I plug in 22, minus 12 is greater than or equal to 8. I bring down my sign because I'm just simplifying here. We're not solving anything. Then I'm going to get 10 is greater than 8, and that is correct. It is still a true statement, so then I can say, yes, that was solved correctly. So now we will look at the next slide here. Really fast. There we go. Okay. So when we're looking at this slide here, rather than a more concise way of writing a solution is to use what's called set builder. We've talked about this briefly. Just writing these fancy brackets here where it says fancy bracket x with a straight line and then the inequality x is greater than or equal to 20 fancy bracket. When we write our answers, we can also graph them, such as here, where we can draw this line, a number line, and then put down that 20 is greater than or equal to, so we need a solid dot because it's greater than, and equal to. And this arrow here where it's pointing towards the right side, that is how I know which direction I need this line to be connecting. So that is one way to help you remember how to draw a number on a number line. Then in our next example here, we're going to be doing subtraction, where we had a similar idea here of if I subtract C from A or B, the inequality will still stay true. Now, in this example, they gave us multiple choice, so I'm just going to just rewrite it first so that we can look at the equation while solving it. So now we have m plus 19 is greater than 56, and I need to solve for that. So in order to remove that positive 19, we need to subtract 19. So I draw down those equal signs so I don't forget it. Subtract 19 on both sides, leaving me with m is going to be greater than 37. Again, I used a different color here for that inequality sign so I didn't forget that it is an inequality sign. Then I highlight my answer here, and you will try the next one on your own. You can pause the video so that you can do the you try while you are working, and then continue on with the notes here. So terms that are constants are not the only things that can be subtracted to the other side. Terms with variables can also be subtracted to the other side in inequalities. So here again, I drew down those equal bars so I don't forget to write my inequality in the end. And I'm going to try to isolate a here. So I need to get all the a's on one side. In order to do that, I'm going to subtract 3a on both sides, leaving me with 6 is less than or equal to a. Then it says to graph the solution set on a number line. So I draw my number line, 1, 2, 3, 4, 5, 6, 7, 8, -1, -2, and then I fill in a solid dot because it is and equal to. And if you notice here, the arrow is pointing to the left, so I need to go in the direction of the left in order to graph this equation. So that is what our graph would look like if we graphed our inequality. You are going to try A and B on your own, and we will go over those in class as well. So pause the video in order for you to do that. Now if we had a word problem, this table summarizes the different words that help us figure out what inequality sign to write. And so I'm going to read this word problem. Felipe needs for the temperature of his leopard gecko's basking spot to be at least 82 degrees Fahrenheit. Currently the basking spot is 62.5 degrees Fahrenheit. How much warmer does his basking spot need to be? So I underline the 2 points of information that I know, and then I look at that keyword, at least. Knowing that it says at least, I'm going to select greater than or equal to sign. And I think about my equation here. We know that it has to equal to 82 degrees Fahrenheit, or be at least that temperature. So if we start writing an equation, we know we need a certain amount added to the total of 62.5 currently, and we know that total has to be greater than or equal to 82 degrees. So I set up my equation, and now I'm solving it, subtracting 62.5 from both sides. Drop down my x, I get 19.5, and I know it has to be greater than or equal to, and that is our answer for this problem. Knowing that if the temperature of the basking spot is greater than 19.5, then it will be the perfect temperature for this gecko. Try the next word problem, pause the video, and we are going to continue on with 5.2. There's only 2 examples similar to this with multiplying and dividing. Then here is your I can statement for the next lesson, is that I can solve linear inequalities by multiplying and dividing, similar to what we were just doing. So here this is showing us that if you have multiply each side of an inequality by a positive number, then the inequality does stay true. So if we see this, 4 is greater than 2. 4 times 3 is 12. 2 times 3 is 6. 12 is still greater than 6. So this stays true. We did not need to change the sign or do anything to this problem if we multiplied by a positive. So those signs stayed true. Now if you multiply each side by a negative, this does not have the same results. If we multiply -7 by -2 and 9 by -2, then we get -14 and -18. No longer is the statement 7 is less than 9 true, because we need to now flip the sign here. Originally it was less than, now it is greater than. This then changes the value of the problem, so because we multiply by a negative, we need to flip the sign of the inequality. So this just summarizes that if we multiply by a positive, it'll stay positive and stay the same sign. If we multiply by a negative, then we need to flip the sign here. So let's put that into action. So on here, if you see, you can also use multiplication inverses. So if we have a fraction, we can multiply by its reciprocal. So I'm going to start by rewriting the problem first. And I draw down those bars to help me remember my inequality sign. And then let's multiply by our reciprocal here, which is going to be -7/3. It's not going to be the negative reciprocal or the opposite reciprocal, just reciprocal, meaning just flipping the fraction on both sides of the equation. And now this is where I'm going to draw a little arrow here, that because we multiplied by negative, so you see -7/3, -7/3, that means I need to change my inequality sign to become greater than. If we multiply by a negative or divide by a negative, we need to flip the sign. So then I simplify from here and get 49. Then they ask us to graph this on a number line. So if we draw a quick number line here, we can say here's 49, 50, 51, 48. Then, since it is greater than and the arrow is pointing to the right, I'm going to have an open circle because it's not equal to, and draw a line to the right. Try example A and C. You can skip B and D, and we'll go over those tomorrow. Then we can repeat this process with division. We can repeat the same process when we do division. The only difference is if we are dividing by a positive number, such as we had -10 is less than -5, then if we divide by 5 on both sides, they just picked a number, then we'd get -2 is still less than -1. So now it's because we divided by a positive number that we are not going to change the sign. But here, in the second example, if we did 15 is less than 18, and we divide by a -3, then because we are dividing by a negative, we are going to need to flip that sign. So notice here how we flip the sign because we need the statement to still be true. -5 is greater than -6. They give us further examples here in the key concept box. So if there's a negative, we need to flip the sign. If it is positive, the sign stays the same. If we're dividing by a negative, then we need to flip the sign, such as there where I highlighted in the purple. Pause the video if you need to and circle that point. So we will finally see this in an example and be done with our notes for today. So if you see that we have 60t is greater than 8, we are going to solve like normal where we need to divide on both sides by 60. So I divide by 60 on both sides. I get t is still greater than, and we're going to get 8 over 60, or if we simplify that to 2 over 15. And in this example here, we left the sign the same because we did not multiply or divide by a negative. And then it asks us to graph the solution on a number line. So I just write out a bunch of 15ths. Since it is greater than, it is pointing towards the right. So I'm going to put an open circle and point it towards the right as well. Then in example B, I'm going to draw those bars again. And we're dividing by a -7 here on both sides. Divide by -7. And because it is a negative, we need to immediately flip the sign to greater than instead of less than. And then write our answer is D is greater than or equal to -21. Write that on a number line, and since it's pointing to the right, then the arrow will be pointing to the right as well and a filled in circle. You can stop the video now, finish the U-tries, and we will go over this tomorrow in class.